Hey everybody, welcome to our first weekly starter video for physics. This week we're actually going to focus a lot more on the interactive notebook as we kind of get it started. There's going to be two parts to your interactive notebook. The first part is going to be the part that I help with. So I'm going to provide content for you, and I'd like you to kind of follow along with me, if you will, but you're not necessarily required to do it exactly the same way that I do it. So I'll show you what I do and then kind of tell you how that works as we go along. The second part is the part that you do. And so this is going to be any vocabulary words, maybe some of your practice problems, extra notes that you found in the lesson or in Class Connects that you thought were helpful, maybe examples that you find throughout the real world that relate to the concepts that we're learning. So those are all things that will be on your side. So we're going to split up the pages. There's going to be the left side and the right side, and honestly, it doesn't matter in the slightest to me whether you put my stuff on the left side and your stuff on the right side, but I would like it to be consistent. So I put my stuff on the left side of my notebook just because I like to, I'm right-handed and I don't like that little spiral bound thing hitting my hand every time I write. So I did it on the left side, but you can do it on the right side and that's totally fine too. You might even like to do it on the right side for the exact same reason I like to do it on the left. I'm not really particular about that. It's just that we're going to have one side be my side and the other side be your side. Oop, sorry, clicked too far ahead there. Our calendar for this week is going to be fairly simple. We are going to watch the weekly starter video sometime between now and Monday, September 12th. Lesson 2.01, as well as the quiz that goes along with that, is going to be due September 13th. The metric system with a lesson on base units is going to be due September 14th. The discussion, which is just kind of a meet and greet, that's from Unit 2.03, and the lesson for the metric system with derived units on 2.04, those are both going to be due on Thursday, and then the 2.06 lesson on measurement and scientific notation will be due September 16th, which is Friday. Really, when I tell you that something is due throughout the week as well, it's truly due the end of the week, but I try to spread it out Monday through Friday so it kind of paces you and allows you to stay current and not fall behind, because sometimes falling behind in this course can be a little tricky. This is going to be your table of contents for the interactive notebook. Again, one side is mine and the other side is yours. So page 1 right here is going to be the base 10 table, and I'll show you what that looks like here in a minute. Page 2 is going to be your reflection and notes from Unit 2.01. Page 3 will be the SI base units, and page 4 is going to be the reflection and notes from 2.02. Page 5 will be derived units, and again, this is all stuff that I'm providing for you, content that I will be providing. And then on page 6 will be your reflection and notes. Now again, if it ends up that, my content ends up on page 2 and yours is on page 3 and then mine is again on page 4 and it rotates that way, I'm totally fine. And if you guys ever have any questions about what the interactive notebook should look like, I do have examples. I have ones that I have done from previous years and one that I'm working on now. So I can show those to you as well as other student examples, so please don't ever hesitate to ask. All right, so our metric system base 10 prefixes. So this is something that you'll get from the lesson, and I really want to use the interactive notebook to kind of help you guys figure out what the important information is, as well as create a resource that will be helpful for you to go back to and look at. So this is just going to be a table. You're going to go ahead and fill it in as you go through the lesson. I gave you the numbers. So when we talk about something that's in 1,000, we have the prefix kilo that we use. So for example, if you're talking about 1,000 grams, we call that a kilogram. And then I'd like you to fill in the 100, the 10. We skipped over the 1 and the 0 because those are kind of a little bit more common sense. And then 1/10, 100th, and 1,000th. For page 2.02, we're going to go ahead and do some vocabulary. So the SI units is, it's actually French. It's Système International. I probably said that in like the worst accent ever, but we're going to go with it. And it's really what used to be the metric system. The metric system is still around. It's just that the SI units are a little bit more widely accepted than even the metric system is. And so we're going to look at what the SI base units are for length, for mass, for time, temperature, the amount of a substance, the electric current, and the luminescence. So the length is really talking about how far. And what I did to get this was I took a piece of paper and folded it in half. So I folded it in the hamburger style, right? So it ended up being the long end that I folded in half. And this right here, this was an 8.5 by 11 piece of paper. So this length here is the 8.5 length. This here is the 11 folded in half, which would make it 5.5 inches. And then I cut tabs into it so that each type of unit would have its own tab. And then on the inside, I just went ahead and I wrote what is the base unit for length. So for the SI base unit for length, it's actually a meter. So if you open up that flap, you would see a meter. Now, this is where I get pretty flexible as to how your interactive notebook is going to look. If you don't want to do brightly colored paper and cut the tabs and fold it hamburger style and all of that, I totally get it. You're just fine. All right. I don't want you guys to stress that it doesn't look just like mine. What I do want, though, is the same content, and I would like it in a manner that's organized enough that you can go back to it and use it as a resource or a reference. So I want to make sure that you have this information. It doesn't need to look the same way, but the content needs to be the same. So however you put that content in so that it makes sense to you, that's totally fine. If you are super artistic and creative and you use, glitter letters, you can do that too and just go over the top. If you are like giving me the stink eye right now as you're listening to me tell you about this and you're like, Mrs. Hart, there's no way you're going to get me to do this, that's just fine too. You can make a basic table. You can write length measured in meters. You can figure it out the way that it makes sense to you. So I do want this to be your interactive notebook. I want it to make sense to you. And I'm not really particular about how it looks. I am particular that the content is there. So again, if you have any questions about that or you're stressing at all about the interactive notebook, just give me a call, send me an email, take a picture of what you have. Most all of us have some sort of smartphone or digital camera. You can just snap a picture of it real quick and email that to me and ask a question, or even just get a seal of approval. So I'm more than willing to do that for you. So the 2.03 discussion, there isn't anything to do for this one in the ISN. You should have already completed it, but you do not need a page in your interactive notebook for that one. The metric system is, it uses derived units. So when we looked at, and I'm going to flip back to this slide here, these base units are truly the only units that we use as standard units in the SI system. The reality, though, is that we use a lot more things than just this that set of units, and so we derive units by putting more than one base unit together. And some examples of these, and these are some pretty common ones that we'll be using quite a bit throughout the course. We have the velocity. And velocity is calculated by the displacement divided by the time. So it's the amount of displacement per time, or change in position per time. And so we end up with the unit of meters per second. That's a derived unit. We also have acceleration here, which is a change in velocity divided by a change in time. So it's actually meters per second squared. Next we have force, and force is what we use, we'll use this one here a lot, but the unit for a force is a Newton, just like Sir Isaac, and it's calculated by the mass times the acceleration. So the unit for a Newton is actually derived by kilograms times meters per second squared. Last but not least, down here we have work, and work equals force times distance, which is a Newton meter, and we use that often enough it deserves its own name. So a Newton meter is a joule, and that's pronounced just like the gemstone, a joule. It just is spelled funny because it's spelled after the person's name. So 2.05 was a your choice lesson, which means that you have the option of doing whatever it is that you would like to in order to stay caught up. It's kind of an extra day, but in order for us to get through the content, I actually have to take all of those out. So every now and then you're going to find a gap between lessons, and that's just a lesson that I removed. Typically they're the your choice days, so don't worry that you're missing that. 2.06 is going to be the measurement and scientific notation. So there's some great vocabulary here that I would like you to have in your interactive notebook. You can go ahead and put that on your side of the page if you'd like. This one here does not need to go on mine, but I would like the picture to go on my side of the page. And this is a great one because I'd like you just to draw some little marks like, whoop. Let's see here. There we go. Just draw a couple little X's. Precise, not accurate. Right? Precise and accurate means that all of them are going to be grouped together. So as you go through the lesson in the K-12 curriculum, you're going to learn the definition for precision and for accuracy. And then you're going to fill this in with little marks and determine whether your bullseyes are precise and accurate, or accurate not precise but accurate. You can have all the different variations there. So then the rules of scientific notation. I'd like you to go ahead and fill this out, and it is actually in the interactive notebook resources, and so you just have to print it out. You could handwrite it as well. Like I said, it doesn't need to look just like mine, but sometimes it's easier just to fill in the blanks as opposed to printing it all out. But your scientific notation, you can create a number here, say 2.06 times 10 to the power of -4. And so it's up to you now to tell me, what do all of these things represent? What is the significance of 2.06? What do we call that? The rules for scientific notation, these are really great ones. I'm sure that you have all been exposed to these at some point, whether it was in chemistry or in algebra or algebra 2. I think even geometry covers this for a moment, but the reality is that this is one of those skills that you touch on in most topics, but you don't necessarily use regularly. We will use it quite a bit in physics, so it's really important to make sure that you have a good, solid understanding of the rules of scientific notation. And this is straight out of the lesson. So for numbers greater than 10, the exponent represents the number of places the decimal has moved to the, and this is going to be either the left or the right. So you're going to have to fill in that blank, left or right. And then this is a specific example. So 625 million is equivalent to 6.25 times 10 to the power of 8, because the decimal was moved how many places to the left. So you're going to have to determine how many steps did that actually move. and this is actually for next week. So we're going to stop at the scientific notation there. Like I said, I don't want you guys to stress about the interactive notebook. I want this to be something that turns into a very useful tool for you. I know kind of in the beginning we're doing a lot of review concepts, so it ends up being a little tedious having to spend so much time reviewing, but hopefully you will find it super useful and it will serve you well this year. If you have any questions, please don't hesitate to let me know. But otherwise, I will see you all in class on Tuesday.